show you today how to make your testing make suck less. So let us shortly introduce. So we are from a digital agency from Berlin. We are about 60 people and we are working in different projects. So we are using this different content management system like Comedia, Magnolia and Content Square, and we are using Java, TypeScript, React and GraphQL. So yeah, we have an open mindset and we evaluate every time, so new ideas from the team, and so what are maybe new technologies we can use. So because teamwork is a big part of how we work, we are also today here as a team, and we want to show you as a team how we work with the testing. So I'm Julia, I'm front-end developer.
I'm Anupam, I'm a developer with a focus on QA and testing.
Hi, I'm Sven, I'm also a front-end developer.
And I'm Daniel, also front-end, but also like full stack and whatever she needs.
So, yeah, and we brought some of our colleagues as well. So, if you have any questions afterwards, go to everybody with the black shirt, with BITGRIP, and ask what you want. So, I think maybe the most of us can help you with the testing stuff. So, let's start.
I mean, given the title that we used, let me call out the elephant in the room. So we are developers and engineers, creative professionals, and testing is typically an activity that holds us back from the playground of creation. And therefore, it's easy, relatively easy to come to this conclusion. Testing sucks, it must be a problem with testing itself. And here at BITGRIP, this is also the conclusion that we drew, because about a year back, our automated tests ran for more than 3 hours for a simple web application, and they were a pain in the ass to maintain. So honestly, testing sucked at BITGRIP until it didn't. So over the last year, we managed to bring this 3-hour runtime down to 15 minutes. So that's a 15x improvement, and we are really excited to share what we've learned through this journey with you. And that is basically the objective of this workshop. Let us take you through this workshop with a hands-on approach of how we did this. And it is a story that involves ice cream cones, hourglasses, and pyramids. So buckle up.
So, yeah, in the next hour, we want to show you how we developed our testing strategy. We will show you and introduce our example we use for the live coding, and show you what is our architecture basics. So after this we go into the test. So we show you something about how we're using our unit tests, how you write some integration tests, and also how you can use screenshot regression tests to be sure everything is working. And after this also we show you something about the API test, show you some end-to-end tests, and then integrate all of this in our CI pipeline. So, if you have any questions, so please ask them after every step. So every time you see this stuff, so ask your question, it's free, and then nothing gets lost.
Could you share the number of tests that was 3 hours?
Yeah, I mean, I'll walk you through that during the presentation. I mean, I have like this segment where I touch upon that, but yeah, I'll answer your question there.
Is there a repository to follow along?
Yeah. This will come soon.
So maybe we open the door, maybe the other side too, because so many people stand outside there.
Is this mainly for front-end testing or also back-end?
It is mainly, we show basically how we integrate, also how we test our front, but also if you integrate the API,
Yeah.
so then it's also tested. So I think it's a bit more front-end.
I'll
But
leave it.
hopefully you also find something with the API attached.
Right, so let's begin let's start at the beginning. And this is where most teams end up when they've just built their first application, right? Manual testing. let me give you an idea of what this looked like at BITGRIP. Our biggest client is a manufacturer of pumps, and we build and host their e-commerce website. We have sprints that typically end with the week itself. So what that looked like was that on Thursday and Friday, we would have like this manual test catalog, which we would divide amongst ourselves. And then once we would go through all the tests manually, we would figure out that a bunch of stuff is broken. And on Friday evening, it would be scrambling to fix it and send the release out. So while people had more, like our friends had more interesting lives on Friday evening, this is what we were doing on Friday evening, and that kind of sucked. So obviously we needed to change something, and we are developers and engineers, and we hate repetitive manual work with a passion. And once we see this, what is our reflex? It's to automate it. You guessed it. So that's kind of what we did, and that took us forward to stage 1. But before we automated it, we had this principal assumption which we made, which is that when we are going to automate, we are going to be doing it as diligently as we did it manually, which means it's close to how an end user is going to be testing it. We did most of our automation on UI and end-to-end tests, and the number of tests we had grew substantially with time to about 150 to 200 end-to-end tests. So that was quite a lot. And that is where we ended up. I mean, to have a number, and this is the, so on automating these tests, we went from stage 0, manual testing hell, to stage 1, automated testing hell. So it turns out that automation, just automating our tests on the UI with that number, which we had, didn't solve our problem. It solved one problem. We didn't do as much manual testing, so it brought down our manual testing load, but it also caused several more. Namely, our tests were slow because that many end-to-end tests to execute one after the other take a long time. Our tests were flaky because that tends to be the nature of testing when you're actually testing on the UI itself. And also, because you are only catching symptoms on the UI, they didn't detect underlying problems as and when we were writing the code. So these are the problems that we faced, and we invested several sprints, a course of a month or 2 in performing this automation. So we were kind of discouraged that we just shifted the problem rather than solving it. And what we didn't realize was that we had slipped into a well-known anti-pattern in testing called the ice cream cone. Now, we are in the middle of summer, but don't be fooled. The ice cream cone is not where you want to be as far as your tests or your code base is concerned. And to describe briefly, an ice cream cone has this structure where most of the testing is done manually or using automated tests on the UI at the cost of integration and unit tests. So there are too few integration and unit tests in this code base, and this is what we had faced. And just to touch upon each of these tests, just to make sure that we are on the same page, unit tests are those where individual components of the code are tested individually and in isolation. Integration tests test these components. I mean, to give you an example, let's say you have an online form with different text fields. Each of those text fields tested individually would require a unit test. An integration test would test the interaction between individual components. Going further with that example, that would be a text field and a submit button, and if that text field is a mandatory field, it needs to be filled before the submit button actually sends the data out. So that would be an example of an integration test. And a UI or an end-to-end test tests a user flow very similar to how an end user would test it. And that's why it's also in the name, end-to-end. And an example for that would be a user logging into the website, navigating to the registration page, filling out the form, and then going on to register and getting a confirmation. Now it's quite important to realize how all of these tests have a different level of abstraction and therefore very different responsibilities. So once we saw that these problems are still persisting and we needed to change something, and from this diagram it's fairly obvious that we needed more unit tests, and that's what we did, and that took us to stage 2, which is the test hourglass. Now, why is this called the test hourglass? we get to see that when we look at this diagram. Now, we still had a large number of UI-based end-to-end tests, but to that we had added a solid base of unit tests. And this certainly helped. This certainly helped because of our three fundamental problems. We saw that one of them at least got addressed. We were receiving more feedback closer to the code and on a quicker basis. The problem still persisted as to how our tests were slow and flaky, and the main reason for that was because we still had a large number of UI and end-to-end tests.
Does that actually mean that you went and the unit tests to your own code base? Or did you create this shape for virtual projects that you can
No, it's more, okay, the question was whether we added tests to an existing code base or we created a new code base. So we actually, throughout this presentation, we are talking about the same project. Throughout the introduction, we're talking about the same project and we're just looking at how the code base evolved, the same code base. Yeah, so this got us to a better state. However, we noticed, there is a particular symptom of landing here as a tech team, and that symptom is we are busier fixing the tests themselves rather than using the tests to find underlying problems. So the tests become an end in themselves rather than a means to finding underlying problem in the code. And this is what we noticed, and we realized we needed to change something. And change we did. We substantially reduced the number of UI and end-to-end tests, mainly by getting rid of a bunch of duplicates or consolidating them into real user flows. Our number went down from about 150 to 200 to we are at about 40 right now. We want to reduce this even further, but this reduction, and most importantly, we took a bunch of those end-to-end tests and translated them into integration tests, and that got us to the third stage. And the third stage is a test pyramid. The test pyramid is a well-known good practice when it comes to testing, and this is how a code base with a test pyramid resembles. It's summarized pretty well in 3 sentences: a solid base of unit tests, an optimal number of integration tests, and a handful of end-to-end tests that test user flows. Now, most of the benefits that we derived in terms of speed came from reducing the number of UI and end-to-end tests, because now we could weed out the ones which are duplicates, and we could also run a bunch of these end-to-end tests in parallel, and this really speeded up our test pipeline in the CI/CD.
I have a question here.
Sorry?
I have a question. How do you define the application of tests? For example, in my company, we have different teams for unit tests and UI tests, and how can we find out which tests are duplicated that we can remove in UI tests?
Right, actually, if you're looking at across units, across different types of tests, if the same unit is tested or the same piece of code is tested using a unit test as well as an end-to-end test, that in itself is not a bad idea because you're testing at different abstraction levels. And how we, at least in BITGRIP, we ensure that the whole team is responsible for writing all of these tests. So that way, the whole team has, every developer on the team has a good overview of how they are going to test the application holistically. Yeah, so doing this addressed most of our burning problems. But once we did that, we did a little bit of a retrospective and we re-examined some of the assumptions we made. The fundamental assumption we had made back when we started testing was we wanted our tests to simulate real user behavior. And certainly as we rise above in this pyramid, this is something that we see. This is a benefit that we derive from writing end-to-end tests because they are far closer to how an end user is actually testing than a unit test. What we didn't realize back then and what we know now is that this comes at a cost. And the cost is that the further up you go, the slower you are, and you also have a higher degree of failure because most end-to-end tests have inbuilt retries. And they're also imprecise because only the symptoms bubble up to the UI. You're not actually fixing the underlying problems in the code itself. So you do need tests that are closer to the code to fix these problems in a timely manner, and those mostly come in the form of unit and integration tests. So fidelity comes at a cost. And what we are going to be doing in this session is we're going to be going through each of these types of tests. And along the way, we're going to also tell you what we've learned in terms of do's and don'ts in building them out. And we can see that this is truly a team effort because different parts of our team will be describing different tests. And what we also see is, at the end, we're going to integrate all of this into a CI/CD pipeline. So that's also something we will be demonstrating. So without further ado, I'll hand over the presentation to my colleague Sven, who will take you through the demo project that we'll be introducing to you today.
So, I'm going to show you like the example project we prepared for this workshop. So first of all, we have like a web application which is built with Next.js, React, and TypeScript, and it also uses a Storyblock, which is like a content provider.
Closer to the mic, just.
Sorry. So yeah, we are using Storyblock. So bad. So we are using Storyblock, which is providing a GraphQL endpoint, and for the GraphQL client, we're using the Apollo client. We can see this example on this page here. So we built like a small website. First of all, we have a teaser, and then we have like a list of jobs where we can filter through the jobs actually. Another thing we also have, like there's an API provided by Next.js, which is proxying the GraphQL API. We just built it for this example project here. We will gonna show this later. So where are we gonna find this example? So we created a repository as well as the URL, as you can see. And we have like cards. We wanted to give them all of them, but now there are too many, I guess. And also everybody was already sitting, so you can have a card when you're going out. So I will give over to Julia. She will present you something about unit testing.
So, first of all, what is helping us for good tests? So, a well-structured architecture make it really easier to test and structure the tests good. So, for example, we are using the atomic design approach. So with this we have small components that we can reuse in larger components. So this is also helping us to structure what we are testing as well for the unit tests. So with this you can see really good what is a small unit and what do you want to test. And later you see better what we will reuse and what you can use in an integration test. So we have well-cut components, and that helps us to have meaningful tests. So, and also we're using TypeScript, and with this it's also, we do not have to check the properties again in the test, so TypeScript is helping us here as well. So, Sven already showed us the example, and yeah, we also use Storybook to have an overview about our components. Okay, so I tried to speak a bit louder, but yeah, we will see. So yeah, here you see our atoms, and that are the smallest components we have. So you have an overview about this, maybe can be tested as a unit, and also we have some larger components, and there we are using the atoms again in larger components. So you have an idea of what I mean with the atomic design. So we will come back later to this for the unit tests. So yeah, But yeah, what is important for a unit test? So a unit test will always test a unit separately and without further dependency. So what is also important for us, that we only want to test the critical parts of the component that we really need for this feature. So with this, we do not have to write a lot of unit tests. That doesn't make that much sense, because already this we did. So we wanted to have a lot of quantity of good unit tests, but not all of them were really good. So it's better to check, okay, what's really your features of the component and make it sense to write a test for this. So, and then you have a good test coverage, and with this, it's easier to refactor your components and also to extend it and to see if everything is working again, so how you expected it. So, yeah, how I already said, the well-cut components help us here a lot, so it's easier to find out what's a unit for us and where we can test it. So, for our example test, we are using Jest and the React testing library. So, let's come to our first examples. So, yeah, the unit I chosen for the test is the list component. So we can have it with a single item. It has a tag, so we can see, okay, what is it for, and then we have a title, and it has a link. So, and it also works with multiple items, yeah. So, for this, I created some mock data, and I have it here with a single item, and also some other stuff with long tag name, with a long title name, and then also some special cases with an empty ID, an empty key, and so on. So what is important here at the first point? For me, it's the variable naming, so you can see it on the first view, so what it is for, the mock data. So, and then when you go to the test, you see it already, what is in there and what I can expect in my mock data. So if another developer comes to this test, he do not have to check, okay, what's in there and wherefore I can need this. So yeah, and then we decided, okay, what's my important features. So therefore I want to write some tests here, but before I write one of these tests, it's important that I have a own instance or an own list instance for each test. So with this, I say okay before each. Render a new list component. And as mock data, I will use my list with a single item. Yeah, and with this, I be sure that before every test, I have a new instance, so they're really separately again. So first, I want to check, okay, if I have the expected number of list items. So I take my component, and before I use the row list item to get every item, and then I will check, okay, if the length there I expected on list items. So here, because it's only one, I expect only one list item. Yeah, I use here hard-coded stuff because I do not want to make it too complicated and too complex. So I think here it's the easiest way to say, okay, with my mock data I expect only one. So in the next test, I want to check if I get the correct title. So I take my my component again, and then I'm looking for the text of the title. And here I can use my mock data again. Take the first list item and use the title I want to have. So I see it here in the mock data. And then I only can check if it's in the document. So, okay, then I know it's the correct item, what's in there. So, yeah. And then we have a special case here, because in the most cases, I try to do not use some markup, HTML markup elements for my tests, because when I want to refactor something or change something, it's not that good to use the HTML markup elements to have it in the test. But here I want to check if the link element is there. So herefore I think it's good to really check if there is an H tag. So yeah. So I can say, okay, I expect again my component, the title. And then looking for the closest A tag. And then I can compare if it also has the correct attribute for the href, and compare it with my mock data again. So I have a single list, and then I can check, okay, there should be the data for the link in it. So yeah, that's the only test where I use these HTML tags. So I'm sure, okay, there is really a link and it has this important href tag, so everything is working. Because also when I refactor, I want to be sure that that link is already there. So the last, I want to test if the tag is there, and I will use the correct CSS class. So I take my component and use again get by text, but now not using the title. Instead of this, I will use the tag. So, and then I can compare if it also used the correct class. So here I know from my component that it should have a default class for this example. So now I have this. So also here, I need some hard-coded stuff because I do not want to make it too complex, because I do not want to have some errors in it from the test themselves. I want to be sure if when there is an error, it comes from a mistake in the unit, but not from the test. So I do not make it too complicated, so it's okay to hard-code it here. So yeah, so first, here are our main functionalities. Yeah.
Is it okay to test for classes in that testing implementation rather than user experience?
So yeah, we also talked about this. So if it's good, we only have some another test, so where you can check some more these visual states. But for us, we also need this for the filtering. So therefore, we decided to check this CSS classes and to have a special focus also on this text. So yeah, so it's a mix of but otherwise it's also that I do not would check for the styling stuff here. So because it's the first step where I maybe refactor something. So you're right. So yeah, and then we will also have here some negative tests. So this is I check what happens when maybe the editor will do not add something he should do. Does my component break? So it's also interesting to have this negative test and not only this positive false. So to be sure everything is working as well. So And herefore we use a helper function, and as well as with the variables, we use here a naming for this helper function, which already says what is happening there. So we have a list item is not in the document, so it should be really clear what is happening here. And what is also interesting, we have a helper function only for this test, and it's in the same part, in the same testing file, and we do not reuse it in another file. So it's good for the next developer who is on this test, so we have everything in one place and see it and read it and know what happens here. So yeah, it's nice not to reuse every time and copying too much, but here it really helps to get a better overview what is happening in this test. So, and then we see it with the variable naming, that you can see it on the first view what is testing here. So we have a single list with an empty ID, and then we want to be sure that this list item will not be rendered in this list again. So our list is working, but this list item is still missing because not every data is here. And this we will check with all of these other steps. So yeah, and then we can check if everything is working. So we use some group here. So with this we can only check this test, and hopefully I make no mistakes now. So, fine, everything is working. Yeah, and I'm really happy. Nothing get lost. So, yeah, and what's the interesting of this? So, to be honest, it's not my favorite to writing tests. So, but I'm really happy about this test when I want to refactor something. So I'm sure it does not break anything, and I do not need something from the QA or something else who tested manual to check, does it still working? So I'm really feeling more comfortable with this. So yeah, with this and with the time, we wrote a lot of more unit tests, more and more, and this is really a helpful and good base for all of our coding stuff. And yeah, you can, I showed it here for a component, but you can already check, so what is a unit for you and how you can use it. Yeah, and also with this you have a good documentation base, but because you see with the negative test, with us it's documented what should happen if something is missing, or if you enter something different content. So there's a description, okay, I expect now that this or that has happened, component will render or not, or something, maybe only a part of this. So yeah, with this we believe that a good quality of the test is more important than a high quantity, and then you feel more comfortable, yeah, about your, that your feature is working. So.
The first question already arises to that topic here, because we have that ongoing discussion at our company like for years when to stop more unit tests and hand over to visual regression tests, because you basically can test with unit tests, you can try to imitate visual regression tests, and you have these trade-off, right? Visual regression tests are took very long, their energy consumption is quite high. You have like thresholds that maybe fail tests or whatever, and you could write hundreds of unit tests to try to figure out how the button really looks like. So somehow I have to draw the line, and it's more a question out of your experience. Where do you draw the line to stop unit tests and hand over and say, okay, that is something totally visually, let's do it with visual regression tests. And, yeah.
So yeah, in my experience, it really helped to have the styling stuff really in screenshot regression tests, because it gives you more comfort that everything looks like it should. And a lot of the stuff you do not see in the unit test. So you see if it's working, if the functionality is there, but about the styling, it's not that much. You know that the CSS class is there, but if the CSS that is not there and does not help that much. And also we have this experience with the storybook that it's also helpful for the documentation for the edge cases, and it's also good to have this in the screenshot regression test. So we have also, you can decide also with Chromatic that you have a lot of screenshot, so a lot of stuff, but not everything in your screenshot regression. So you can document it, and then you can check, okay, what's your base you want to check, and maybe some edge cases, but they are really important. Okay, then also use a screenshot regression for this, and then have a base what is documented, and for the functionality you have the unit test.
Sam, the question was just, we were basically to the process mainly as unit or last year or whatever, with visual versions, because we had a larger project with basically a couple of thousand visual versions, and it took basically 4 years to run that through, right?
Yeah.
And so, yeah. Okay.
What tools do you use for screen?
I will show you later, and I will show you later more stuff with the screenshot regression. So, yeah, but first, before we go to this, what happens when more units come together? So, therefore, I will give over to Sven. And yeah, how do we check interactions between units?
You can hear me now? Yeah. Yeah. So, how can we check interaction between units? So we can check that by integration tests. So by the definition, integration tests test the interaction between various modules of an application. For example, in our project, we're gonna test the interaction between different React components or the interaction between different layers. So, but to simplify the answer, like how do we write integration tests? We test like a user would test interactions. Like you go on a website, you click on something and see if something changes on the site. So that's why we are also using React testing library for this, because React testing library was written with this background to actually test like a user would test stuff. Furthermore, we're gonna use MSW to mock some responses we get from GraphQL, and then we're also using Next Page Tester, which is just rendering the page we're gonna test like Next.js would actually render a page. So we'll call the same functions and so on. So how does an ideal integration test look like? So as I mentioned, it should test as a user would test an application or layers. So we should have more an interactive approach to testing. How does an application react to specific user actions? So actually, what we're gonna test today? So in our example, we're gonna test the integration of Storyblock into our page, as we saw when I showed the project. So we have an index page, and we're gonna check the interaction between the GraphQL and the page and every component which is in there. So yeah, but what we don't want to do is actually call the Storyblock GraphQL, because in automatic testing we want to avoid to have like external dependencies, because external dependencies will always break, you know this. So that's why we're gonna use MSW, which is intercepting the network request in the network layer and not in user-land code. So then we can ensure that all this stuff works, even like the Apollo client also works as how we integrated it. So let's go to the actually implementation. I need to close something here. So therefore, I already created like an index page, index test, sorry, which is laying under tests. So what we're gonna see here. First of all, we have like we're testing the home page. Maybe I can show that again before what we're actually gonna test. So we test this side. First of all, we write a small test, or I already wrote a small test, which is checking if the teaser is rendered correctly. and then we're going to write a test, like when we click on something, for example, on the front end button, that only like a specific list item is shown here. This is what we're going to write. So, how are we going to do this? First of all, we have this. We mocked the story block GraphQL endpoint with MSW. So we're gonna use like, we say, okay, there are two different queries running on this page. First of all, we have get page content, which is rendering the teaser, and then we have this query called get job list, which is rendering the job lists. So therefore, we just respond with some mock data. But what we're not mocking here is like the Apollo client. We're just directly mocking the actual request here. So then we will have, I already wrote a test, which is like testing just simply if the correct headline is shown on the page. Then we have a small simple test, which is testing if some jobs are displayed. Actually, when we want to write this correctly, we should extend it also that it checks like if the correct number of jobs is shown here. But just for this purpose of this example, we just do simple test, and then we're gonna write this test, which is already shown here. Wait a second. So we're gonna delete this. So, okay, let's write it again. So, create a new test case. Oops. Yeah, that should write correctly. Test should further be just something, we write something here. So, what we need to do next is we need to actually render the page. This can be done with the next page tester. So we just return the render function and say get page, and then the actual root, which is the same again. So we say root equals home folder, and then we actually render the page. So what we want to do next is just we want to click on the specific button and see how the UI changes. But first of all, I want to show you like what the actual render function looks, or what we already have now. So we can use like a debug function, which is called screen debug, and we want to debug everything. So that's why we need to say, okay, it's undefined. We don't want to debug a specific element, just screen, and just return whatever, how many lines you want. Just put something in here, and then when you run them, you can already see. Wait a second.
You will see the weight.
Oh yeah, you're actually right. Thank you. So it's async and then wait. So I also wanted to add a group here, as we saw before. So we only run the specific test. Integration page, for example. So now we can only run this root, sorry. Integration group. So let's see. Oh, page. Yeah, thank you. Live coding. Woo. Integration page. Let's see. Let's find something. Yeah, we found the index. So this is what we actually see on the screen. In this screen constant. So as we see, like this is like a DOM representation of the home page. So what we now want to do is like we want to click on a specific button, which is called front end. So we see here we have a button with the name front end. We can find this by just, or we can click on this when we're using user events, which is provided also by MSW. User event, click, and we want to get the element, so we say get by role. We want to have a button, and just using regex here because typos. So that's how we can click on this event. And so now what we want to check is that first off, in the other test we checked like if operations engineer and senior front-end engineer is available, and now we want to check that senior front-end engineer is still available and the operations engineer is not available anymore. So how are we going to do this? First of all, we just check again the same line. We expect the same thing, so we can copy that over. Test this, and then we want to test the absence of a specific component. So we're using wait for, and then we expect that the specific element is not available anymore. We do this by the screen query by text. And we query the same text again. And then we say, okay, it should not document. In the document. So let's see if this works. Interesting. So let's run this again. We already removed the debug line. Okay, great. So we're going to test this, see if it still works. It actually works. Ooh, nice. So yeah, that's like how we write integration tests. Just to summarize, like what we actually did is like we tested now the integration of the list component and the list items, and we also tested the integration between the GraphQL layer or GraphQL client, Apollo client, and our code we wrote. So, but the question is, like, how we can we ensure that like it also like looks visually like we want? Because right now we tested like just DOM if it's like the structure is correct, but we don't know if it looks correctly. Therefore, we're gonna write visual regression tests or show visual regression tests. First questions. Oh yeah, sorry, we don't have. There are any questions? Okay. So I give over back to Julia.
So, yeah, now coming back to the screenshot regression test. So, what is this and what is this for? So, the screenshot regression test has to find some visual changes. So, yeah, with this I found some invisible cross effects inside the components. So, yeah, for these we using Storybook and Chromatic as a combination. So, how I already showed, we have the Storybook with our components here, and there we have beside the default styling and the default case, we have also some edge cases. So we are using it for a long label. We have it here with a check filter, and also for some other stuff on the list, we have it with a long tag name or long title name, and we are sure that it looks like we want. What is also nice, we can have it here for different screen sizes. So yeah, it has not every screen there, but we have some of the most important screens here, and see it really good if it also works on, for example, a tablet or mobile view. So yeah. So, and on the other side we have Chromatic, and Chromatic takes this cases from the Storybook and do some screenshots, and then it can compare, okay, does something change? So on the one side it has the old data or the old base with how it looked before your changes, and then it compares check your new changes, and then, okay, what's the difference? So, yeah, it's my favorite test because I do not have to write some tests. So, but on the other side, you have to do some manual work with the comparing of the screenshots. So, yeah, herefore I will change something and say, okay, let's say our text do not have any border radius anymore, and let's save this. Let's build new to check, okay, how it looks like. And yeah, in our example here, you have not that much component. So yes, it would be also working that you're clicking through everything manual and check, okay, how does it look like? And maybe also for every different screen size. But it's not that typical project. So in the most cases you have a lot of more components, and then okay, I know I have here the tag, I see, oh yeah, nice, I have no border radius anymore, but I'm not really sure, okay, maybe where I do use it also. So maybe sometimes you forget it. And then it's deployed, and then you see, oh damn, there were some other changes I didn't recognize. So herefore it's really helpful to have this screenshot regression. So yeah, I have now did my change, and then I can commit it and run my chromatic. So, and with this, it shows me all the changes, where this comes. So now I see, okay, how I expected. I have some changes in my list, and what is really nice, I also can say, okay, check this for all the different screen sizes. So with this, I'm also sure that I know how it looks like in the mobile screen as well. So, okay, now I see here the difference. So I have no border radius anymore, and I can, with the screen stuff, I can see, here's the change. But I also can toggle it so the diff is not shown anymore, and I can see it before and after. So now I have to check, okay, if it's something I want to have or not. So here's the manual work I have to do, so I can accept it and say, oh yeah, that's what I wanted. So, and also for the other stuff. So, but as well, I see here, okay, oh, there was another component. There are also changes with this styling change. And yeah, therefore it's good. So, because I see everything, and also in every viewport. So now I can check, okay, is that what I wanted, and say I accept it, and then it's the new base for only other changes. Or otherwise I can change it again in my code and correct it. So, and also we integrated this in our process, because sometimes you do some changes, but you're not really sure if it's really this what your project manager or your UI also, is it really this what they want? So then we show them the chromatic changes, and they can see what they will get afterwards really early in our project. So you do not have to deploy as merge and deploy everything, and afterwards at the end of the sprint they will say, maybe it's not that really what we wanted. So therefore we also use this, and here they also can comment, okay, no, maybe have a small border radius, not that much but a bit, and then you can change it really early. So yeah, and this is how it helps us for have an overview about these visual changes.
Can you say again how this baseline images are created? I mean, are they stored somewhere, or are they created on the fly again? Can you compare this to live?
So it's build once with your first base. So, and then also when you have a new component, then it's integrated as a new change, and you have to say, okay, yes, check, that's fine. So my component should look like, and then it's a new base for every after change. And then when something will come new to this, then you will say, okay, accept to get this to the new base. So it's this process.
Is this somewhat sensitive to changes in the rendering engine of the browser somehow? I mean, if they change like the font style to anything or stuff, and is this sensitive?
Maybe I can say something to that. So Chromatic provides something which is called like upgrade your infrastructure. So you know before, like when they upgraded it, and they already know that something will change, so they have a kind of intelligent algorithm which checks like, okay, that's only a change from browsers, from your browser, but from time to time.
But what's with real data, and does it all still working when it's deployed?
Is it possible for us to see the code coverage? I mean, how much is discovered and how much is left from?
Yeah, in this demo, we haven't dealt with code coverage, so we haven't turned on any code coverage for this project. I'm sure.
I do not know if it makes really sense, because it's only to have all the tests here to see it and show you, okay, how you can use it, but not to have a complete project here. So.
But for unit testing, for example, we do have code coverage, in our pipelines.
Okay, I just asked because is there a way to attach it to Sonar plugin or Sonar plugin so that you can see the test reports and see how much code is covered, how much uncovered lines are there, and so on.
As far as you're talking about unit and integration testing, then the answer is yes.
Okay.
But not for the visual regression testing.
I mean, we're not sure. We haven't.
Yeah, or I rephrase that we haven't used Sonar Cube, or we have investigated it with visual regression testing. What we have done is for the other two.
Jeff can create a XML and it's a report, and you can see the coverage there. And GitLab can read this file.
Thank you. All right. Perhaps one last question before we move on in interest of time.
Now
Yeah.
the coverage was mentioned. What's your code coverage?
What's up? I think code coverage on the project that we're speaking about is roughly about 75. So 70 to 75 is what we have from a unit and integration testing perspective. So mostly unit. That's where we're actually doing the code coverage measurement. All right. So moving on to real data and real world scenarios. As I mentioned, we go on to the last layer of the so-called test pyramid. And on the test pyramid, now we come to a place where we are looking at interactions that are happening as end users are likely to experience them. So we've split this segment into two parts. The first part deals with API tests. What are API tests? Now, API tests are pretty simple. So you have an API endpoint on which your application depends. You're only testing if this API is delivering a response that is in line with what you want, both from the perspective of the code as well as from the data that it's transmitting in the body. And a valid question here is, where do you fit API tests in your test pyramid? A good argument can be made for fitting API tests into integration tests, but we choose to club them into end-to-end tests for primarily two reasons. Because as you saw in the integration test, we are mostly dealing with mock data, and with end-to-end, with API tests, we are actually receiving API endpoints from other teams. It could be a backend team, it could be a partner team, but teams that are delivering this data to us. Now that's one reason, but the most important reason is API tests combine extremely well with end-to-end tests, and we found this in our experience that once you have a failing API test, you don't need to analyze maybe the 10 end-to-end tests that are failed because of this one API test failing. Give you a simple example. Take an e-commerce website and there's an API endpoint that is delivering prices of articles on this website. Now, if there are end-to-end tests that test the checkout of an item or a product catalog, once the price endpoint fails, those tests are likely to fail as well. So you don't have to spend time investigating why they failed and so on. So just save a lot of time by using them in tandem. They work well together. The framework we are using to demonstrate both API and end-to-end tests is Karate. And the sole reason we chose it is because it's one framework which can handle both kind of tests. And it worked out pretty well. And it also has a simple Gherkin-like syntax, which is fairly easy to follow in a live coding session. So let's take a look at some code. I'll open the appropriate repository here. Yeah, so this is Karate, and it's a Maven-based. The build tool that is used in this project is Maven. And so for starters, let us preview an API test which I've already written, and we can extend this as we go with some live coding. So first of all, the app that we previewed has these job listings, and these job listings are received from a particular API. And this is what we'll be testing out. And this information, firstly, you have all the jobs which are coming in. Secondly, you also have this filter functionality, both of which rely on this API to function correctly. So to that end, if we're looking at the first test, it's fairly self-explanatory. When we look through it, we are in our given statement, we have a path which is the jobs endpoint, given that this URL that we have on top is the base. And when our method is get, we expect a 200 as a response, and we also expect the titles in the response on the various objects that the response returns to have the jobs that we have on the site. So I'm gonna pause for 5 seconds to send my prayers to the demo gods and then demo these tests. Alright, my prayers have been answered for now. So let's look at, what also Karate enables us to do is, from a reporting perspective, it gives us a nifty report where we can look at how the execution has happened, with how long it took, and we see that it has executed in line with what we expect. Now what we already see here is that this particular test, to make it easy to understand and follow, I've used really specific test data. Now, if there is a partner firm which is delivering this API result, it could happen that these jobs are not in this particular order, right? And therefore, what we do in our real-world tests is we just verify if there's a string response at the endpoint, and that pretty much suffices. Nevertheless, we found that for even end-to-end tests, it helps to have our tests in integration environment where we have more control over the data, and that integration environment obviously has to be as close to the production as possible, but we don't usually test data in the production directly. So having said this, we could also extend this integration test to test that filter functionality, which is what we'll be doing now. So I'm going to write another scenario where I'm saying filter jobs by tag. And we'll be using that tag that we saw with the jobs to filter them out. And I'm going to start pretty much the same way because the endpoint is the same. And I'm going to add another parameter here. And then the status code is also going to be the same. And now I'm going to ensure that each response. Now we can see that the response we receive from the first test is under the key jobs, and then you have a JSON array, right? So what I want is every element of that JSON array to have the tag QA, because now I've filtered with the tag QA. So I'm going to say match each response dot jobs contains the tag QA, and let's fire away. So it also executed successfully, and we can see from our report that we now, under this scenario, we have two scenarios here, and also the new one that we've written, just to make sure that this is not false negative. Let's just change that to something else and expect it to fail. And it fails. Precisely where we expected it to. So let's change that back. Now here are a couple of points about API testing as such. We can see how they are minimal effort and high returns. So when I spoke about having a minimal number of end-to-end tests, I did not actually mention API tests. What we are looking at, what we want to minimize is the UI-based testing, because this is usually not the bottleneck when it comes to your test pipeline. And my favorite use case for these API tests is for contract testing. When you're working with other teams who own a particular API, these APIs are documented, but how often have we seen that documentation is not current? How often have we seen that something changes without information flowing to us at the right time? And for these sort of changes to not break code in production, it's great to have a layer of contract tests whereby we take the responses that we expect from our partner firms, either teams within our own firm or also externally, and verify them from an API perspective if they are giving us data that in line with what we expect for our application. So that's pretty much it for the API tests. Do you have any questions before we move on into the end-to-end or the UI-based tests?
Are you using databases here? Like, are you going through the database, or are you using like on memory databases?
So your question is
like for the actual data that you are testing, you are not testing against production. I mean, the database, are you using in-memory databases, or are you going to a real database in a development environment?
Yeah, how I understand, so we actually, our partner firm owns this API, and with our contract tests, what we do is, usually we have two different environments where this data is stored. Do we have clarity on whether this is in-memory or real?
Actually, in this demo project, there are no databases.
Yeah,
on our side.
So you don't control that API, like that API is external. You're only checking like.
That's what we wanted to simulate here. Of course, in the demo, we created that API, but we're trying to simulate that we don't have complete control as a team over this API data, and despite that, how are we going to work with this dependency?
For example, Storyblock, the CMS we are using, it has its API. We are not controlling it, but we want to make sure it works as we expected. And we wouldn't do it in reality because we trust Storyblock. But we have some partners we don't trust it that much. We want to make sure the API responds well.
I have a question. Like the end-to-end test, you maybe show later. When we open your page on browser, then we see the job listing, right?
Yeah.
And that data is coming through the API response. So when I write an end-to-end test on browser, at the same time API calls are happening. API calls are happening. So why we need separate API test?
It's a good question, and the reason I mentioned was because, I mean, there is some redundancy here. We are testing the same thing twice, essentially. But that said, you know, the same API endpoint could be used in 5 different end-to-end tests. And once we have both these reports, you know, if you're running both the API and end-to-end tests, if one of these API endpoint fails, it saves you the time from analyzing all 5 end-to-end tests which failed as a result. So it's just a method of consolidating. I mean, the problem is if we have only API tests and not end-to-end tests, then we don't know if the end user actually has the experience they're expecting, so that's suboptimal. If you have only end-to-end tests and no API tests, then we have to analyze 5 tests and why they're broken as opposed to 1. So that's why it's a good trade-off to have some bit of redundancy and include both. Great, so moving on to the next section. Which is to do with end-to-end testing. Now, with end-to-end testing, I think the most crucial part to understand is to limit end-to-end tests to really critical user flows. A more accurate but less catchy title for this session would have been how to say no to end-to-end tests, or how to do most of your testing in a robust manner without end-to-end testing. And this is what we found has worked extremely well by reducing and minimizing the number of end-to-end tests we have. And we can see practically with some code examples as to what I mean when I say that. So let's open the first end-to-end test and look through the syntax as such. So the first thing that we'll be doing is actually quite similar to what we also did in the API test, like you mentioned. First thing we are doing is we are ensuring that all the jobs are listed out as we expect them to, and then we are going on to filter for front-end jobs and QA jobs. Now let's go through the scenario. The scenario is called filter for a suitable job and make an application. Now this is really important, I want to emphasize this. We put and make an application in brackets because a real life end-to-end test would actually have that sort of a scope. It would not just filter for jobs, but it actually go ahead, make an application, get the confirmation, and then pass. We wouldn't be covering this in this demo because it's out of scope, but we want you to take home that message, and we want to emphasize that message that what we are previewing here from an end-to-end test perspective is about 20% of what an actual end-to-end test would be doing. And then, what we do is we navigate to the website, we check using HTML classes for the tags that are corresponding to these jobs to ensure that we have all the jobs listed out, and then we also verify this filter functionality. Let me first execute the test, and then let's go into some analysis. So now we see that we are actually executing both the API tests and end-to-end tests together. Just saw the browser open up, but it was really quick. And now we have a summary where both the API as well as the end-to-end test has passed. And we also see that each of these steps have been passed. So let's see, what we're doing I'm just going through a little bit of detail here. What we're doing is we are enabled the front end tests by clicking on the tag, on the corresponding tag on the website. And then we are ensuring that the front end jobs are there. And we're also ensuring, initially we verify that not just the front end job, but also the QA and back end and so on were available. So we also, in the second step, exclude QA jobs. And we fail the test if a QA job exists. Now I know that this is not foolproof because it could filter out the QA jobs but still have the backend jobs. For example, for the sake of convenience, we did this, and it's not 100% perfect, but it's good enough. And usually with end-to-end testing, we see that good enough works, good enough with large coverage in terms of a user flow works better than crossing all the T's and dotting all the I's. What we also see is important to notice is there is just one scenario here. Although I'm filtering QA jobs and front-end jobs, also checking if all the jobs are displayed on the page, I don't have 3 scenarios. This is completely different from how we do unit testing, where we are testing small modules and we are keeping the tests as small as possible. Here I'm deliberately including all of this into one user flow rather than splitting them up into 3 user flows and then having to run them again. So this is also the consolidation that we did also was a huge benefit that we saw in terms of performance. But at the same time, while consolidating, make sure that if you are using 2 user flows, they are not dependent on each other. So you should be able to independently execute them so that you are able to run them in parallel. Let's go ahead and tweak this end-to-end test or expand this end-to-end test to include a case whereby on the website, we also have certain tags which have no offers available. And this is something also that's important to test, the absence of certain information rather than just the presence. So let's go ahead and check that functionality. So let's say we have architecture jobs, and when I click on architecture, I expect to have no jobs available. So I'm going to say when. It's pretty much the same line, so I'm just going to copy it. And I'm going to change this to architecture. Oops. Now just confirming if this is correct by looking at the DOM. Yeah, looks about right. And then once I click on this, I expect this text message, no offers at the moment. And in order to find this, I'm going to go back here and say, then match text inside this element, and let's find that element. Now I'm just going to use the CSS class here. And I'm also going to remove spaces and add dots there. Ensure that it's available on the DOM and then use it in the test. And this text for the text of this element, the text content, has to be what we expect here. No offers at the moment. So now we are also testing a case. Let me comment that as well. And run all the tests. All right. So we now see that this scenario is passed as well. Yeah, go ahead.
Just a question about the selector. So you're using the CSS class as the locator for the element. Is it a good idea to do that? Or because as she mentioned that it's also like the first point of changes, right? So then it's a little bit risky and real to do that.
Absolutely. This is something that we've considered. The most elegant way would be to use, say, use the attributes themselves like buttons or text fields or whatever the underlying components which are less likely to change. The real reason we chose that was for ease of following it during the demo. So, in a real life scenario, you would choose a more stable HTML selector. But there again, rather than go for the most optimal solution, we just go for a good enough solution. In most cases, that tends to work pretty well.
Have your team thought about using like a data attribute or something like that? Because I've seen leaking everywhere, and how do you feel about leaking? I mean, not leaking, but they're in the DOM. You can see it, and it's marvelous.
Yeah, this is another project that we're using data attributes for this, and we have own data attributes only for the testing. So therefore, you do not change anything when you refactor when it's cycling or something like this. So yeah.
Should be like
Yeah, we use test data attributes in the real projects.
Okay.
Yeah, so a few good practices worth pointing out with end-to-end testing. Google recommends, we're looking at the test pyramid. Google recommends a split of 70, 20, and 10 when it comes to unit tests, integration tests, and end-to-end tests. That's a recommendation. Your mileage may vary, but so that's what is considered a good practice. We also found that duplicates tend to accumulate very easily in end-to-end tests because two different developers writing the same test without being aware of their existence. So it's always good to ensure that duplicates don't creep into your code base, especially with end-to-end testing. And yeah, the point I emphasized about user flows is something that I want to reiterate. What we see here is about 20 to 30% of a real-life end-to-end user flow. Yeah, so are there any further questions on the topic?
I have a question. So you said in the beginning that you tend to lower the number of UI tests, end-to-end tests, and you focus only on the critical stuff. So do you do the same for the API tests as well, or you tend to cover more with API?
With API, usually what we do is if we have, let's say, 10 different endpoints that we have documented, and we tend to test at least all these documented endpoints once. And we include further tests for functionality of these endpoints, using something like a parameter for the ones where they are more critical. So it's more comprehensive for the API tests. We don't try to minimize our numbers there because they execute in milliseconds.
Yeah, okay. And the second question is, where do you keep the project? In the same repository where the front end is, or do you keep it separate? And why?
You mean where do we store our API and end-to-end tests?
Yeah, end-to-end tests.
We currently store them, we're going off topic from the workshop's perspective, I'll actually give you an answer to this. We store them currently in X-Ray, which is a plugin of Jira which we use for testing. And we are still actually questioning that decision because the assumption then was that non-technical people like our product owners will be writing tests and they can write it in X-Ray. But we found that actually didn't work out in practice. We might actually integrate those things back into the repository because, something like source code management is not actually there inside X-Ray. So you tend to lose all of this data. You don't have history. Versioning is what I meant. Yeah, you don't have any versioning in X-Ray. Any further question? Okay, so then we've looked at a bunch of tests, a variety of tests across the test pyramid. Now, given that we have all of these tests, how do we ensure that they work well together? So what do we do with this multitude of tests?
Yeah, so thanks for staying with us so far. I saw a few of you dozing away during the session, but that's fine. You heard the CEO this morning. In only 5 years, we can sleep 80% of our time and write those boilerplate tests 20% of our time with Copilot, of course. Yeah, and he also talked about happiness, and we are happy. We at BITGRIP we love writing tests, right?
Doesn't suck at all.
Yeah, with Copilot it's even it's a breeze to write them.
Are you allowed to use it in your company?
Oh yeah, we haven't. Should I think about it? Okay, because of. Okay.
So that's not actually today. There's some measures of social lessons.
mental note. I should discuss this. Right now I'm using it, I'm trying it out, but yeah. And I trust them that telemetry is only anonymous and stuff. But I don't know. Yeah, happiness. We are happy. And we also want our users to be happy, so we prevent this, right? So we are not writing the test just for fun. We're using them. So I take this pyramid here, our testing pyramid, I turn it around, and then we use it as a quality gate. This is a very simplified scenario here. So on my local machine, I commit and push my code, and then something happens. And hopefully not on my machine. I mean, I can do stuff on my machine, but when it comes to automation, I want others to do this stuff, right? So I push my code, and then I have a server or a continuous integration platform. Some machine takes my code and then performs some checks, and then the test pyramid comes in, and my unit tests get run. My unit tests run, my integration tests run, and also my end-to-end tests. And in the end, my server can also deploy my website, my code. And yeah, for this demo project, I tried out GitHub Actions to do this, to implement this workflow. And I can encourage you to try it out if you haven't, because it's so simple. I mean, I hadn't used it a lot, just a bit before, and it's so easy to implement my pipeline from checks to running the tests and deploying even to Netlify. We hosted this in Netlify, and it was a breeze to do it. So I show you now how we did this simple workflow. 3 fingers right. I'm not used to Mac. I'm showing you GitHub now. Zooming in, because I know it's so tiny on this. Oh, it's big. Yeah, this is our demo project. It's public now. We wanted to squash all the commits, but we haven't. So don't look for secrets. We have pushed to this repository. I go to GitHub Actions, which is their CI pipeline platform. I don't know what's the term here. And for every commit I do for specific branches, I can define on what branches it should run, and I can also have a nice workflow integrating the pull requests and so on. I cannot go into too much detail because I haven't tested it here. But what I did for this project, I took basically the tests that my colleagues had written here and created a pipeline, and I played around with it. So I played around with those metrics unit tests, where I can say I have a similar type of test like unit tests, and only one thing is different, like the group. We showed it before. We can use a plugin to run just unit tests grouped by a group. Yeah. And I did this here to just to play around with it. Maybe it's not necessary. I can run all the unit tests in one job. I think it's called job here. But I can also split them up to have separate reports and so on. I then told GitHub to run the integration tests after the unit tests, and that's not necessary. I mean, I cannot run everything in parallel, but I can also, fail fast, right? Maybe the integration test take up a long time, and then the pipeline is blocked. Maybe I don't have enough resources. I mean, GitHub hopefully has enough resources here. I don't know. But I'm glad to run, for example, the screenshot regression tests after the integration tests and some of my basic tests, because we pay for it. Because if we have a lot of yeah, we pay for it, right? I mean, even in our projects, since it's a cloud-based service, they make you pay for diffs, I guess, or anything you push. Every screenshot. Oh my. Okay. So it's a good idea to don't do it when something else fails, right? What else do I have here? Yeah, I mean, the project should be buildable, so I have a build step here. When it's not building, it cannot be deployed by Netlify. And also, build time on Netlify, they make you pay for it, as you might know. So I don't want to deploy and make Netlify deploy stuff if it doesn't build. Yeah. And strangely, it's not necessary to build the app to run unit tests. So why? Okay, so I can show you. Oh, there's even a chromatic report. I didn't know this. Yeah, someone was talking about this XML file, right? Where you can look into coverage. The same goes for our other tools. Just Chromatic, they create some files where I can create reports of. And yeah, I saw.
Yeah, question about including the sprint regression test in CI/CD. If someone needs to go through and actually accept those, how then you already have it in CI/CD, because still someone needs to actually go and check and accept those changes.
True. I don't have experience how this works here in GitHub Actions, but in our projects we have Jenkins as our pipeline that runs stuff, and we have Bitbucket connected to Jira. I mean, it's more Atlassian, right? Bitbucket. And somehow we integrated Chromatic and Bitbucket that we have a build failing, and then how does it work? Do I click on? Yeah, I then got redirected. Basically, it's failing, and it's telling me. I even get an email: go to Chromatic and review the visual changes. Then I go there, and when I'm done reviewing and everything is fine, then Bitbucket somehow makes.
Just sending like, okay, now it's passed.
Okay.
So first of all, I'd say it's waiting for something. So it waits, and then you can accept everything, and then your pull request gets accepted basically. So it's a manual step before you can merge stuff. So it's only in a CI, not in a CD. Like this.
Yeah. So good question. I haven't tried it out here with GitHub Actions, but I mean, I haven't wrote anything myself when I built this pipeline. We have a lot of templates. I guess even on the Chromatic side, you can look up how you build a nice integration with GitHub Actions. And GitHub Copilot creates everything for you anyway. So, what else can I show you? Maybe I can show you how the pipeline breaks, but what's this? This is our project, right? Yeah. Okay, we have this env. Can I reset this? And can I reset? Is the env is not committed to it? So I can just revert the changes here. Okay. I'm also not used to Visual Studio Code, sorry. So yeah, it's so simple to create this pipeline in GitHub Actions. It's the same with Jenkins, and I guess GitLab does the same. You create a file or multiple files. Here it's a YAML file, and then you declare your pipeline. And then you have to read the documentation, and it tells you everything about what is a job, what is the workflow itself, and then I have a use case. Like, is it big enough? I have a use case. What's this use case here? Yeah, I have a use case I want to check my code, and I already have a script ready for this. Yarn lint. I can run this locally, and I should.
why would I wait for CI to do this? But it's fine to have my CI, of course, to check it. And yeah, I can look for this use case, and then I get examples, templates, and then yeah, this pretty much is this usual use case how to run some scripts, right? It fires up some an environment, I guess with Docker or whatever, some virtualization. It sets up Node, and yeah, it creates it uses a yarn cache. So my colleagues, Jan was introducing the yarn cache here, right? Because it was slow. And yeah, and then I can also say my job needs something else to be green beforehand. If I don't do this, then it runs in parallel. Yeah, I don't want to go too much in detail here. Maybe I can go back to the slides. So this is this workflow is not the reality. I mean, it's very simplified. Just to tell you, we use the pyramid as a quality gate, because in reality, of course, I mean, at least we are using feature branches to curate features away from the main branch, because we are a team. If you work alone, you don't have to deal with all the problems here maybe, but in a team, we have like 5 feature branches, and in about a day, everything gets integrated back. But I want my feature branch also to be green before I integrate it with the other code. So locally, I can run my unit tests here. That's the yellow bubble, the unit tests. I can run them locally, and then I commit and push, and then the machines are running, doing the checks, running integration tests and unit tests, but not the end-to-end tests, of course. But because what would I run the end-to-end tests again when I have nothing? What we do, we deploy my feature branch to a feature deployment. So we have a running website only with the code of this feature branch. This is the red bubble here. So I run the end-to-end tests against my feature deployment. And then when this is green, and my colleagues are fine with my code, I can merge, and then my code goes back to the develop branch, and we integrate all the nice features we have. And on the integration, we do the same. We check everything, because I don't have to explain to you. If you write a test and I write some code, I might break your test, right? And vice versa. So I run everything again. What we also use, we only run a subset of end-to-end tests on our feature branches, or even on our CI deployment actually, which we call smoke tests. Maybe that's a term widely used to say we don't run all our end-to-end tests because we want to have fast feedback, and I don't want to even wait 15 minutes, right, for tests to run. How long are they running right now?
It takes about 3 to 4 minutes.
And 90 tests?
The 90 tests take 15 minutes, but then 15.
Okay, I don't even want to wait 15 minutes so to get quick feedback, yeah. So we do the same on the developer branch. We run every tests and we deploy to some environment that has all the code integrated. Questions?
Is there a way to double check or ensure that the tests that you have written in your feature branch have been carried over to the integration test or in the development branch? So like if you test the development branch, is there a way to ensure that tests for the new features have been carried over?
So you can add some test sets where you define your smoke tests. And you need to be smarter in the manual part for sure to add them also to the later regression tests. So it's kind of the manual work there to put the correct test cases to the smoke test or to the regression test. Or both.
Something you have in your checklist then? Or in your
also doing deployments and running the pipeline for every feature branch. But I think it really depends on the size of features you have, because if your feature is really small, does it really matter if you're is it worth it to run the whole pipeline and pay for the image regression test and all the stuff for every feature? I mean, it makes sense if your feature is really big, but does it work out for you guys to do that for every feature branch?
We also think about this. I think most of the tests don't cost us, but the chromatic regression tests actually cost us. That's why we don't run them on feature branches. Only when we are done with our work, I'm done with my work on the feature branch, and then I create a pull request. Only then I think we trigger the chromatic test. So it's at least something we think about when doing, but it doesn't cost that much.
So depending how big is the application, even a small change can break everything. So it's a kind of risk management. So if you say, okay, I take the risk, then don't do it. Then if you say, because my application is so small, I'm sure nothing will break. If you're not sure, then you should run the test every time.
Also thought about adding Git hooks. So I've worked on a project. I didn't add this, so I don't know what dependency was it that actually made this possible. But every time I tried to commit, it ran all the linting and unit tests before I even could commit, and it said, oh,